What's up guys, welcome back to the Arduino HMI project, and in this video let me demonstrate to you the application of the project to monitor and control a class A power amplifier with its minimum casing, and how I achieved that with the minimum heatsink like the one I have here right now. By the way, this is an AMP analog circuit, and I call it to be Michelle TACA. Well, let's talk about that later on, but what I would like to mention is that I'm using the Arduino project to monitor and control the heat dissipation of this mini Class A power amplifier. Let's dive for that. Let's see how the digital brain control the analog heart. But wait guys, if you are not following the Arduino project or never heard Arduino HMI or Arduino A3CS before, this video might be a shock to you. So I suggest if you haven't know Arduino project before, I suggest that you watch my Arduino video series from the introduction and its application. In this video is my introduction of my personal project called AMPduino. I put the link down on the description below. Just click the one and it will take you into the Arduino project introduction. This project, I call it to be Michelle TACA. It is an implementation of the Arduino A3CS. It's basically a derivative of the Arduino project. This is the digital brain from the Arduino Uno to control the analog heart, the AMP Class A power amplifier. This circuit is basically a clone. The PCB design and its form factor is a clone of the AMP. You know guys, let me deep down to square one, because this board that is being used right now is called the Arduino A3CS. That is the Arduino shell that can easily interconnect all the external sensors to the Arduino Uno. I do not use the HMI LCD on the front panel. I wanted to have only the real analog VU meter instead of the digital display. Hence, I do not use the word Arduino HMI. HMI means human machine interface. Instead, I simply use the Arduino A3CS, which is the shield that interconnect all the external hardware. Having said that, powering up and powering down the Class A amplifier, it's a much novel with a series of blinking LED. It's a form of communication, between the amplifier and you as the user. The Arduino A3CS is a fully dedicated for the Class A power amplifier, basically to monitor the heat generated, especially in a small casing with a minimum heat sink. This is a challenge actually in Class A power amplifier, because Class A generate a lot of power. I discussed in my previous video about the mechanical revolution by using a small heatsink in a Class A power amplifier. Many people don't like it, and many people don't believe that I can do it. But anyway, this is DIY and I can implement whatever I like. But guys, look at it. I spent lots of days and weeks to study and understand how much heat is being generated by the Class A power amplifier based on this form factor. I've been trying to understand what about the heatsink ability to dissipate that kind of heat being generated by the Class A power amplifier. I've been using my tools, my DAQ tools, to monitor the heat on the surface of the heatsink, also the surface of the MosFET. And then I generated a kind of report so that I can study what is the threshold, what is the standard and minimum and maximum heat on this particular form factor of this heat sink. And I got them. I got them. And then I'm going to transform those information into a logic and codes that I can write into the Arduino sketch into a form of instruction so that the Arduino project can monitor the heat being generated by the Class A power amplifier. The biggest question from my friends is that is it really feasible to use a small heatsink in a Class A power amplifier? Is it or not? Well, I have shown it already with the Nathan Winter Camp. But anyway, this is what I like. Again, this is a DIY. The idea that I have in my brain, I download it and put it into a real action. As simple as that, and that is the reason why I started this Arduino project. Started to teach about the beauty of programming the Arduino Uno using the Arduino solution in order for you guys to do it also in your own DIY ways, in your own DIY design, to implement it into your own DIY project. Whatever amplifier you have it right now, this project can be used to your power amplifier. In the first project where I use the Arduino project, it's the Nathan Winter Camp. Sometimes we call it as a Campana amp. This is basically a derivative of the real ACA, the amp camp amp, designed by Nelson Paz from the US. The circuit is basically the same, but the form factor and the PCB design is different. And I use basically a pulse width modulation on the exhaust fan in order for me to control that heat generated by the amplifier. That means to say that the heat or the speed of the fan is proportional to the heat being generated by the Class A amplifier. Means to say that the lower the heat, the slower the fan, and the higher the heat, the faster the fan, so that the exhaust fan will going to accelerate, remove the heat being generated inside the casing of the Class A, the Nathan Winter Camp amplifier. For the hardware implementation, I make use of a precise thermistor that is installed into the heatsink. One is to monitor the minimum, that what I call it the threshold, like at 55 degrees, and the overheat started at about 65 degrees. These two thermostats will going to set the detection by the Arduino A3CS, wherein it start to monitor the 55 degrees and also the 65 degrees. Another DHT11 is used to monitor the inside casing temperatures. That is mean to say that aside from the precise thermostat, I'm using a DHT11 to monitor the air temperature, the heat inside the casing. All right, guys. That's what I have in this video. I hope you like it. I hope you like the Arduino HMI project, and you voted it as a solution to make your power amplifier front panel looks better than what you have it right now. And stay tuned to this video because I'm going to continue the Arduino MMM and the Arduino HMI project with more external hardware like the sensors, the volume controls, the temperatures, fan, and so on and so forth. Well, enjoy your favorite music. Enjoy listening to your own design power amplifiers. Enjoy the hobby. Bye for now and see you in the next video.